Somebody move this thing again. That's like a regular. I'm recording? I am recording. All right, so let's start on number 8. A trap for insects in the shape of a triangular. Um, if I get distracted one more time, I'm just going to pick up your paper. All right? Let's focus. The area of the base is 3.5 inches squared, and the height of the prism is 5 inches. What is the volume? What do you do? Okay, that's it, right? So we're talking about a triangular prism, right? Something like this. And they happen to give you the area already, right? The area of this guy is 3.5 inches squared. They say inches squared. This tells me that's the area, inches squared, not just inches. Whereas this one is just 5 inches. That's just a measurement of the height, right? So because it's a prism, you do not have to divide by 3 at the end, right? You only do it for pyramids. So you multiply these two, and what do you get? Inches what? Why is it cubed and not squared? The volume, people. Volume is cubed because you put cubes in stuff, right? Arletta built a cardboard ramp for her little brother's toy car. This thing right here. Uh, Identify the shape of the ramp. What is it? The shape, what is it? Triangular prism. Why isn't that a pyramid? Oh, the sides are rectangles, not triangles, right? And then why is it not square prism or a rectangular prism? Another reason why? Why is it that you can say that's a triangular prism and not a rectangular prism? Look at it. Why is it that I can say that is not a rectangular prism? Okay, that's one way. Yes. That doesn't have much to do with it. Look at the shapes. What? That's one way of saying it. What's the other way? There is not two rectangles, but what are there? There are two triangles. That's it. That's all I need to hear. There are two triangles in there. That means it cannot be a rectangular prism. A rectangular prism only has rectangles all over, nothing else. So when I see that, I'm like, there are two triangles. There's no way that could be a rectangular prism. It doesn't matter how I sit it. So a lot of the kids thought it was rectangular prism because of the base looks like a rectangle. Where it's sitting on, not the actual base. The base is right here, right? So what is the volume? Now that you know that, some of your volume might be wrong. How do you find the volume? Area of the base times the height, which is what? 25 times 6, what does it give me? 250? 150? Yeah. Divided by 2? Because the triangle? 14? Oh, 75 is 75. And then what do you do with that? And what do you get? 525 inches cubed, right? That's it. That's your answer. The what? You have to have both because you have two different questions. Identify the shape of the ramp, and the other one is find the volume. Half a point. Half a point. All right. Sandy, yes. Then it's wrong because it's not squared. Guys, if you got the wrong units of measurement, mark it wrong. Yes, you have to have inches cubed, not inches squared and not just inches. Two different things. All right, Sandy builds this shape of 4 congruent triangles, meaning they're all the same, right? Using clay and toothpicks. The area of each triangle is 17.6 centimeters squared. When somebody says squared, they're automatically talking about area. Remember that. And the height of the shape is 5.2 centimeters. It has no exponents. That means it's just the distance. What's the exponent of 1? What three-dimensional figure does the shape Sandy built resemble? What does it look like? What? Triangular pyramid. Okay. If this were a solid shape, meaning that it has volume, what would be its volume? What do you do? Uh-huh. What do you get? Okay, don't worry, I'll do it. 12 carry 1, 14, 5 carry 1, 3. 30 carry 3. Hang on, 35 and 3 is 38 carry 3, 8. What do you get? Yep, 91.52. Are we done? What do you do? Why? Duh, right? You divide by 3 because it's a pyramid, and you get 30.06 or something like that. 35? Oh yeah, you do. It was 30.506 something. Yeah, that will work because it says to run to the nearest tenth. So, what number? Then you have a point. All right, the next one. Will tripling the height of the triangular prism triple the volume? How can you prove that? How can you? No, you're explaining. I'm saying, how can you? Give me an example. Let me just give you an example. Let's say that the area is of something, the area of the base is 20. Show me that I can triple the height and get triple the volume. So let's multiply this by 3, assuming that the height is 3. What do you get? 60. So if I triple 3, hang on, 20. No, tripling 3 is not 6. It's 9, right? If I triple the height, this is an example. If I triple the height to 9, what do I get? 180. Now tell me, is 180 3 times as much as 60? Absolutely. That's how you prove it. That's all you have to say. Yes, when I triple the height, the volume also triples. That's it. Are we good? Awesome. Jackson went camping on in a state park. One of the tents that they took is shown. What is the volume of the tent? How do you figure it out? Yikes. Why do you multiply 4.5 times 6? Ah, explain why. Why did you multiply by this by this? What? Why did you multiply that and not by 6? Yes. Thank you. That's what I wanted to hear. But you didn't. I need you to say it. Do not be afraid of the answers. Even if it's wrong, I still want you to say it. So 4.5 times 3.5, and you're doing that one, not 6, because the base of the prism is a triangle, right? It's called triangular prism. So how do you find the area of that? Matthew? Times 4.5. And what do you get? Huh? What do you do with that? What do you divide by 2? It's a triangle, right? Good job. So what do you get when you divide by 2? Yes, feet squared, right? What do I do with that? You multiply by 6. And what do you get? Nope. By 6? That means you multiply it by... Point to what? Cube, right? We're talking about volume. No, you don't. Why is it that we don't divide by 3? It's not a pyramid. It's a prism, right? If it's not a pyramid, if it doesn't look like the ones in Giza, then it's not a pyramid. Huh? I showed you last time, the pyramids of Giza. Remember when we went on Google? Oh, it didn't. That sucks. Well, I'll show you in a minute another one. All right, move on to the next one. Chantel is solving a problem involving triangular pyramid. You hear her? Listen, everyone got confused with this one. You'll hear her say B is equal to 24 inches. That's all you hear. She's not writing it down. She's not telling you whether it's area of the base or little b. She just said it to you. And you cannot change those words. That's what she's trying to figure out. Let's say I'm over here and I tell you B is equal to 24 inches. And you listen to me and like you write down B equals 24 inches. You get back to your group and you're like, do you mean area of the base B is 24 inches? Or the measurement of the triangle, the base is 24 inches? How do you figure it out? Okay, so let's look at this triangle right here, right? This is the height, right? This is what? That's the little b, right? That's the little b, just the measurement. However, to find the volume, we have to find capital B, right? Which is the area of the base. Base times height divided by 2. And let's say that you get in the volume of a triangular prism, and I just told you B is 24 inches. And then I walk away, and you cannot find me because I can't say anything else. How do you figure out that I'm talking about this little b or the area of the base? By what I said only. And you cannot change my words. You can't divide anything. I said b is equal to whatever. It doesn't matter what number it is. But how do you figure out that this b that I'm talking about is the capital one or the other one? Because this could equal something. This will equal 6, and this will equal 7, or whatever. It doesn't matter. But both b equal something. I'm asking you, how can you figure out what I'm talking about? It is. It's not very easy unless you know your values and your units of measurement. Think about it. I'm going to give you one example. If you go to the store, yes, go ahead.
I don't know. I noticed that. Oh my God.
Okay, so let's go. Let's assume you go to the store and there's this one item. Imagine an item and you want to buy it. And you go to the clerk and you ask him, how much is this? And then he goes, 5.
5 what?
Exactly. 5 what? So you have to go back to the label and see if it says $5 or 5 cents, right? That's exactly the same situation here. I just told you 24. And by my words, you have to figure out if I'm talking about a length or the area or what. Yes. Why? Okay. But he didn't. He just said B. That's it. You have to figure out by the whole word. The square. Okay, so what do you think it is? Why? Perfect.
Really?
He said 24 inches. He didn't say 24 inches squared.
Oh,
I know, isn't it?
it makes me mad.
Well, it should. I know. If, like I said, if I give you the problem, whatever you're buying something, if I say 5, you need to know which one I'm talking about. So that's it. Yes, because he said or she said 24 inches, you automatically know he's talking about a measurement. He didn't say squared or cubed. Huh? Most likely. That's a really good question that I would put on a star. All right, the next one.
Oh my
I know. Just the next one.
I can't chill. Sorry. So, what's next with that?
She just.
Oh my
There's
God. I can't tell if it's
B, the base of the actual triangle.
alright. I don't get it.
And it, again, guys, it is the lowercase b, because the way he said it, he did not say anything about squared, so it has to be just a measurement. When I give you a measurement, it's just in centimeters and inches or whatever. When I give you the area of something, I say is this squared. When I give you a volume, it's this cubed. What? What?
Oh my God. Okay.
Go ahead.
What about the example that you had gave? How would you find that?
Rude. Okay, let's read it. I'm sorry? Go ahead.
But how would you find the answer of that example that you had gave? Or you would just like,
The answer.
you know how you said about really? Yes, I want to know.
Oh, okay, let me explain it again.
No.
This one?
I don't. She's talking about the store. How would you know if it was done?
You have to go back and look at the actual label and see what it says.
Why would she ask the guy?
Because she's lazy, she's already there. But
God.
but I'm saying if you go back and look at the actual label, then you can see where what it says, right? All right, so the next one. Alex made a sketch for the homemade soccer goal he plans to build. This soccer goal, we're gonna call it Pedro's. Pedro's goal. There you go. Stay on it, Pedro. It's yours. The goal will be in the shape of a triangular prism. The legs of the right triangles are the sides of his goals measure 4 by 8 feet. Okay? And the opening along the front is 24 feet. How much space is contained in there? How do you figure it out? What do you multiply? What? 6, 8. What do you say 16? Or 4 times 8, what do you get? 32. 2, and then you get 16. There you go. You need to guide me. So volume equals area of the base times height. So in this one, the area of the base is base times height divided by 2, which is n times height. 8 times 4 divided by 2 gives you 16. Multiply it by 24, what do you get? 384, right? Feet, not 3, cubed. There we go. Oh, all right. We're going to move on to the next part, which is what we did yesterday, a little bit of surface area, right? When we measure, find the area of all the faces of a figure. So this right here is a triangular prism. It has 2 triangles, the top base and the bottom base, and then all the sides are rectangles. As you notice right here, these are all rectangles right there. And then we're talking about a net. I asked you all ago what a net was, and not a fishing net. Get up, buddy. Come here. Click play on that. That's a net. It's the shape, and basically it unfolds itself, and it creates a net. That's really what it is. Click on this one, the rectangular prism. There you go. Now look at that one. It works the same way. A net is basically the same shape, but it unfolds itself. Do you see that? Click on the pentagonal prism. The third one. That one's really cool.
It looks like a cross.
Now the next one. Pedro, the next one. That one looks kind of like a drum.
Cool. It looks cool the way it folds.
So I'm going to post this on Edmodo so you can play with it. It tells you the number of faces, vertices, edges, and all that stuff. What I'm trying to show you here is that if you notice, they generally leave the both faces as the wings. You can have a seat now. So whenever you're looking at a net, the top and the bottom bases are out like little hands, and then the body is right here. That's important because when I ask you for the lateral area, I'm talking about just the body and not the little wings. So for the lateral area, I'd be talking about this right here, all the squares. Not these, not the wings, just the squares. If I was talking about this one, it'd be the same way. Just the wings and not the square. I mean, hang on. Stupid thing. There you go. I'm talking about just right here. That's the lateral area. Not the wings, just the whole body. Do y'all see that? That's very important when we start doing the next one. And it works the same way for the triangular. Oh, dang it. Okay. Pyramids are very similar too. Actually, pyramids are cooler. Because they have a lot more shapes. See that one? It's the same way. And it folds the same way. This is called a tetrahedron because all the shapes are the same, all the sides are the same. Then you have the rectangular pyramid, and it folds like a star. They all unfold like a star because they don't have square sides. They're like triangles, so either fold in or fall out. And they're really cool. I think this one looks better because it's like a big star. Totes, right? All right. So we're going to move on. Fine. There you go. Okay. All right. So let's go and look at our page, our paper, not on paper. Where'd it go? On page 332, I want you to work on number 8 and number 9 individually. I'll give you a couple of minutes to finish it. All right. Find the lateral area of the shape. Miguel, I want you to explain to us since you're so busy over there talking. How do you find the lateral area? I don't want you to give me the answer. I want you to tell me how to do it. So, I'm talking about this one right here. And how do you find the lateral area of that? Miguel, I'm not asking you to do it. I'm asking you to tell me how to do it. Each with a tongue. Let's go. What are you multiplying? We don't. So no, you do not multiply. We're actually finding the area, right? And the lateral area is, like I show you with this thing, you can open that shape the way that you can open this one. So you can have the wings on the side like little triangles. Like that. Do we know this side? Right here. What is it? The long line is 6, right? But what is this right here? Like 4.3. Yeah, it is 4.3. Yeah. That's 4.3. And then what is this right in the middle? 3, right? And then what's this right here? 4.3. No. Oh, I may have. Okay, so what do we do now to find it? You add all of these, and what do you get? 21.6? What is 4 plus 4? 11.6. That's 8, and then 3? That's 11. 11.6. What do you do with that? Multiply by the length, right? By 6, and that gives you the entire thing, right? So when you multiply 6, what do you get? 6 times 6 is 36. 6 carry 3, that'll be 9 and 6. 69.6 centimeters squared. Oh, that doesn't go there. It's right here. Now, what is the total surface area? What are we missing? The little flaps, right? The little arms. So what do we do? What? Yes, find the area of both and add it to 69.9, right? So how do you find the area of the triangle? Peter.
Like 4 times 3 times 3.
Pedro knows. How do you find the area of this, Pedro? Tell me. It's a triangle. What do you do? Huh? For the area? How do you find the area of that triangle? What do you multiply? 4 times 3? What do you get? Then what do you do with that? Not quite. I'm looking just for the area. What type of shape is it? And we said triangles are what in reference to a rectangle? Half, right? So what do? You divide it by 2, right? So 12 divided by 2, what is it? 12 divided by 2 is not 3. It's 6, right? So the area of this is 6 centimeters squared, but we have 2 of them. That makes it 12, right? So add 69.6 plus 12, and you get 81.6. No, not 0.6. Yeah, you do. There you go. Centimeters squared, and that's for the whole thing, right? Good. All right. We're going to do this one right here. It's kind of cool. So, yeah, 81.6 centimeters squared. I think so. No, I don't know. All right, looking at that box, how can I turn that into a net? Open it up. Where do the top and the bottom land? What are they going to be? What are they going to be, though, as far as the shape? The wings, right? I'm like, I can see. Okay, so that means that this part and this part have to be the wings, right? Wing. And then wing, right? And then this part is right. This is the top. This is the top. This is the bottom. Imagine that I opened it like this. It's not really. If you look at it, imagine that I opened it from this side. I grabbed it from here and I pulled it that way. So I'm looking at the back of this right here, and then the back of it right here is right here. This just went up. This came down, and the back of it is right there. I just went like, and okay. So if this is 8, and this is 2, that has to be 8, right? What is this? Are you sure? Imagine if this was 8 and this is 12. Would it be able to match? No, they have to be the same size, right? Otherwise, they won't close. So that means this must be 8. So this is 8, and 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 that's 2. So what is this? That's the 12, right? This is 12, 12, 12, 12, 12. That must be 2 and 2. That's it. We have all our measurements, right? They're in there, 12 and 12. And the little ones in the middle are 2. All right, so find the lateral area, which would be obviously all this, right? And then give me a total area. Go. Same thing, I know that. Like, how do you not know that? Well, you have to notice that there's in between. I left that one intentionally, so you have to go and like figure it out. This is what I do, guys. When I'm adding them, this is what I do. I go one by one. 8, and then I find whatever's next. 10, 18, 20. When I add the values at the bottom, you have to do it piece by piece. Otherwise, you're going to skip like he did because you didn't look at the ones in between. Highlight piece by piece to make sure you have all the measurements. So 20 times 12, what does it give you? 240. So that means the total surface lateral is 240 inches squared. And then for the other one, you just have to add the wings, right? Which is 16 for each. So 240 plus 16 and 16 is 32, right? That gives me 272 inches squared. And that's it. It's a very simple one, right? Well, because I actually do like these problems, and they're kind of cute. So I will have you, that will be your homework, the rest of the page. They don't look that bad. Look at them. Yes, you do. The other one is because I need you to get better with volume. I know. Yes. Hang on. Do not forget your homework from Edmodo, which is already posted. Ta-da, right there. 10 problems for you guys, and then every class had different problems.